The lecture today is going to deal with Chapter 4, and we're going to look at isotopes. Now, we've mentioned isotopes before in previous lectures. These are atoms that have the same number of protons but different numbers of neutrons. And they show almost identical chemical properties because, remember, we talked in the lesson yesterday that the chemistry of the atom is always due to the electrons that are the social interactors of the atom. In nature, most elements contain a mixture of isotopes. So let's look at them a little bit further. Here's an example of two sodium isotopes. So here's sodium. It has a mass of 23 and it has a proton number of 11. And this one has a mass of 24 with a proton number of 11. And notice that the proton number doesn't change because protons are the personality of the atom. Okay, let's take a look at what's going on inside of the nucleus. So here's the nucleus, and I just kind of blow it up a little bit for us to see it. There are 11 protons and 12 neutrons in this nucleus for a mass of 23. In this nucleus, there are 11 protons and 13 neutrons for a mass of 24. So these are two isotopes of sodium where the number of protons stays the same because protons are the personality and the number of neutrons is different. All right, we're going to learn to write isotopes and how to write atoms and electrons and protons and identify those. And this is universal. So why these particular letters are chosen, I really don't have an idea, but we're going to go with it. So when you write down the information about an atom, what you're going to do is you're going to write down the symbol, and the symbol is going to go right here. So this X represents the symbol. And that would be Cl or He or H, or it depends on what the element is. Remember to always capitalize the first one and lowercase the second if there's a second letter involved in that. Z, that's the atomic number. That's going to go right here, and that's the number of protons, which is the personality of the atom. A is the mass number, which is the number of protons plus neutrons, and that's what goes up here. So this number on top is always going to be bigger than the number on bottom. Now, as long as there is not anything right here where this box is, there's not a plus something or minus something here, this is a neutral atom. And if it's a neutral atom, remember we said yesterday that the magnitude of the proton and electron were equal, so it will have the same number of protons and electrons, so that the overall charge is going to be 0. We'll get into charges and we talk about ions, but for right now you need to know that this Z right here is the number of protons, which is the personality, and if there's no charge, that's also the number of electrons. Okay, here's an example. We're going to write out this for carbon. So C is the symbol for carbon. The atomic number when you look at it is 6. And 14 is the mass number, so 6 protons and 8 neutrons. The symbol for carbon that has a mass of 12 would be written like this. So still the X or Z in this case, let's just write that out from the other page. So X, Z, and A. So this is what our X is, the symbol. This is our A, which is the atomic number. And then this is our Z, which is the mass number. So these are isotopes because in this one, if you notice here, we can subtract. This one has 8 neutrons, and this carbon atom has 6 neutrons. Now I've gone to the site webelements.com, and I wanted to look at a periodic table. It's set up similar to the one that we're going to be using in our classroom, and it has the periods labeled down, the groups are labeled across, and we're going to talk about the makeup of the periodic table in this chapter as well. But what I wanted to bring to light is those numbers that I got for carbon, for example here. I just wanted to show you where they come from the periodic table. Let's take a look at one of the exercises they have. It says a certain isotope X contains 23 protons and 28 neutrons. It wants to know the mass number of this isotope, and it wants us to identify the element. So let's write down the information. It says a certain isotope. So X, remember we have X, V, and A. X is going to just be X, so we don't know what that is. We're going to find that. It has 23 protons. That's its A value, right? That's its personality, are the protons. So we're going to put 23 down here. and it has 28 neutrons. Remember that Z is the number of protons plus the number of neutrons. So we're going to take 28 plus 23. 11 carry your 1 is 51. So this number becomes 51. The next step is to look at the periodic table, and if you take a look at your periodic table, we want to look for number 23 because that's the proton number and the personality. And if you find proton number 23, atomic number 23, it's V for vanadium, and it has an average atomic mass of 50 point something, so it's right about 51. So this one has 51. It's an isotope instead of 50, and it has 23. So that's how you would write this isotope. Let's look at one more example. Let's say that what I want to know are the number of protons, the number of electrons, and the number of neutrons for plutonium. So this is what the periodic table has on it. And the first thing you need to do is to put it into this form. So PT becomes the X. The Z is the larger number. It's the protons plus neutrons. So we're going to round this to the nearest whole number. So we're going to put 195. And then our personality or our proton number goes down below, which is 78. So if I look at this, my protons are going to be 78 because that's the identity and personality of the atom. My number of electrons, because I don't show a charge out here, is equal to that, which is 78. And to find the number of neutrons, I'm going to subtract 195 or 78 from 195, and it has 117 neutrons. So on your homework assignment, sometimes they will give you just the element and say, find it on the periodic table and give me this information. This is how you would do it. Otherwise, they may give you like 198, 78 PT. And this is obviously an isotope. It's not 195. It's a heavier atom, 198. And when they give you information like this, then you're just going to go ahead and use that information to identify what your proton, electron, and neutron numbers are. So again, 78 for protons. There's no charge here, so it's 78 for electrons. And when we subtract the two, we end up with 120 neutrons.